Okay, good morning once again. The last aspect, the last new thing, not necessarily the last because we still have the Newton's method, okay? But the last main stuff, if I may put it that way, is the method of integrating factor for general solution. The Newton method, you use that to get a particular solution, kind of. But anyways, for general solution, integrating factor method is another important technique of solving differential equation. You see, we started with direct integration, isn't it? We started with if you have dy dx is equal to f of x, you do direct integration. Remember that? Then we proceed to, if you have dy dx is f of x comma y, we write it as a product of x, function of x and function of y, and we use separable variable method, right? Then yesterday we discussed homogeneous equation. They cannot be separated. However, you should be able to write as a function of y over x on the other side. Then you use the substitution y is equal to vx. And of course, this leads to solution as well. Okay, now the differential equation that we're talking about does not belong here, cannot be solved this way, cannot be solved this way, so there is need for another approach. Okay, the differential equation will be of this form: dy by dx plus a function of x multiplying y is equal to something else on the other side. Again, dy by dx, a function of x multiplying y, this time around equals to another function of x, which means it's not of this form. Because if it was of this form, you know, this could have been maybe px y minus qx, isn't it? Equals to 0. Or we could have said dy by dx is equal to qx minus px times y. But this is not a factor like this. Am I making sense? So you cannot think of separable variable in that regard. I want to be sure that everybody gets what I'm saying. Can I get some gesture to be sure that everybody gets what I'm trying to say? Yes. So when you get to this point, then you know you are dealing with integrating factor. Again, you have a direct integration if you have only function of x on the other side. You just integrate directly. Okay? If you have a function of x and y such that you can factorize and separate them as products, then you know this is a separable variable problem. If you have a function of x and y such that you can write the function on the other side as a variable y over x, then you are using the substitution vx for y. Then this is homogeneous equation. If you do not have any of this, look out for this pattern. After dy dx comes a function of x multiplying a single y. Are you listening? After dy dx comes a function of x. This could be exponential, this could be logarithmic, this could be algebraic. Okay, after this derivative comes a function of x followed by 1y. Then transfer every other thing to the other side, which means if the question looks like dy dx plus sine x y minus 4x equals exponential x. You can see after your dy dx comes a function of x and y. All you have to do is after your sine x, y, transfer every other thing to the other side. This becomes your qx. Okay? If you have this kind of situation, you are dealing with integrating factor approach. Okay, problems like this can be solved using integrating factor. So let me write a short preamble. You are free to write. A differential equation one sec, please. I think it's better now. A differential equation of the form dy dx plus px times y equals qx can be solved using the method of integrating factor. Okay. This is because the problem fails to be of any of the three forms previously discussed. And by the three forms, I'm talking about these three forms. It doesn't belong to any of this that we have discussed earlier. Okay? So I'm going to now tell you about integrating factor. It's in your formula booklet. Let me see if it is indeed in your formula booklet. Share your formula booklet with you. Here. Can you see? In fact, that is the only thing included in your formula booklet. Integrating factor for y, this is dy dx, pxy, qx. The integrating factor is exponential px. We will derive exponential px together now. You don't have to know how it is done. I just wanted to show you. And the last one is this Euler method as well. And that involves a table. And that's it. That's all about differential equation. Okay? Now, yeah, my pen is working now. Yeah. All right. You see, let me tell you the idea of integrating factor. The idea is that if you have your dy dx plus pxy q, you will find an integrating factor let's say a function ix is your integrating factor. We will multiply the integrating factor to both sides, but we will carefully select this, okay? So that when you multiply integrating factor to the left-hand side, which automatically gives this, okay, the left-hand side will then become the result of the product rule of multiplying integrating factor by y. Okay, of course, this remains what it is. Then in that case, you can now say, oh, if I want to remove the integral, the derivative, all I have to do is integrate the other side. Again, this is the problem given. We will find an integrating factor that is a factor you can multiply something with. What is the factor of 12? 6. Okay, we get a factor of 6, for example, and multiply by something. There's a reason for finding the factor. Okay, but a factor that makes the left-hand side integrable. We will carefully choose this factor ourselves so that when you multiply this factor to both sides, automatically this left-hand side is a result of differentiating this by product rule. Okay, which means if you keep y constant, this is it, and you differentiate ix, you will get this 2. And if you keep this constant, this is it, and you differentiate y, you get this as well. Okay, that function is what I've just shown you in your formula booklet. That function will always be integral exponential integral of p dx. You will see how that becomes so in a bit. So the idea is to make it integrable, or you cannot integrate directly if you do not convert it to that product rule form. Am I making sense? That is why we call it integrating factor approach. Okay, so given y by dx plus pxy is equal to qx. Okay, let's multiply both sides by an integrating factor. Ix, so that our left-hand side dy by dx plus, okay, ix first, so that ix dy dx plus ix pxy is equal to ix qx. This is what I've just multiplied both sides with. Okay, so that this becomes the ddx of x times y. Ix is not given. We are choosing it ourselves. We are choosing it carefully so that this becomes that. Okay. So the equation is equation 1. Let's call this step equation 2. Okay. From equation 2, so that ixy will then be the integral of this dx. So that the y that you're looking for, are you with me, everybody? So that the y you're looking for is not going to be 1 over ix integral ix dx, ix qx dx. This will then be the solution of the equation. Okay, this is then how to solve it. But before we get to how to solve it, what is ix? For ix, to determine ix, okay, can I have everybody's attention, please? Everybody, please pay attention. Don't write. Please pay attention. Again, let me go back again. Given this problem, we will multiply both sides by the integrating factor ix, so that the equation 1, okay, so that equation 1 becomes this. Okay, are you listening? So that equation 1 becomes that. Again, the purpose of multiplying by ix is to make sure that this then becomes this. You are choosing ix carefully ourselves, so that at the end of the day, the entire thing here is actually going to be this. So if you reverse it, you do product rule, you must get this back. That is the kind of ix you will choose. Your ix must be chosen so that if you do the definite product rule to differentiate this, you will get this back. Now, if we are able to get that ix so that this happens, you will see that the entire problem here is now here. If you now want to make y the subject, when you solve an equation, it means make y the subject, isn't it? Right? That's the whole purpose. To make y the subject here, then you have to integrate the other side and you have to divide by ix. Then this will become the general solution. This is how to solve it. But then you need to now know what is that ix that you need to multiply both sides with. Can I see a hand if you understand what I've said so far? Okay, great. Now let's now find the ix ourselves in the general form of the ix. To determine ix is the integrating factor because it varies with the problems. To determine the integrating factor, let us look at the left-hand side. Let's look at here and here. Okay. To determine ix, left-hand side of 2, okay? I'll simply say 2 becomes, when you differentiate this, keep ix constant, right? Differentiate y, right? Plus differentiate ix, are you with me? And keep y constant. Differentiate ix and keep y constant. So this is our equation 2. Hello? Understand? This is our equation 2. Compare that to, maybe I call this 2 and I call this 3. Let's call this 2 and let's call this 3. In that case, I will say from equation 2, from equation 3, this is what happens. Remember, I said at first, we are choosing ix so that everything here becomes everything here, right? then what kind of ix we give that? Let's differentiate this ourselves. We will get this. Let's now compare with 2. Okay, compare with 2. If you compare with 2, what does 2 say? It says ix dy dx is equal to, no, plus what? Let me hear your voice, so I'm sure you understand what I'm saying. Plus what?
ix.
Speak louder, sir.
Ix pxy.
Ix pxy is equal to what? Ix qx. Just trying to derive ix here. You don't have to worry about it in the future. It's already in your formula booklet as well. I'm just trying to show you how it is derived. Again, we said that we need integrating factor to multiply both sides so that the left-hand side becomes this. If the left-hand side must become this, it means both of them must be the same. That's what we are trying to do, right? If both of them must be the same, the left-hand side here is this. The left-hand side here, maybe I remove this one. The left-hand side here is here. Sec. While the left-hand side here, let's use green for that, is this one. Am I making sense? If you have chosen ix so that both of them must be the same, then you can compare both sides. In that case, we can say that what? Anyone? If you compare 2 and 3, then you can conclude what? Together, everybody.
I prime x y is equal to ix pxy.
Does everybody agree with him? So it means that I prime x y must actually be the same as ix px y. No, there's no need for y. There's no need for y, Mr. Chen. Then this must happen. Hello? Understand? This must happen. So what does this mean? The implication of this is that I prime x divided by ix must actually be px. Yes? If I integrate both sides, integral of I prime x, Karen, I'm going to ask you a question now. Dx is equal to the integral of px. Karen, what is the derivative on the left hand? What is the integral on the left hand side?
ln absolute value of,
let's pretend is positive. Okay. Is equal to, right, integral of px. Callista, you know the purpose is to find the ix. In this case now, Callista, what is my ix?
exponential
of
the integral of p of x.
Integral of p of x. This is how the ix you saw in your formula booklet was derived. So you don't need to worry about what I've done from the beginning. You only need to remember or be able to use the last results we have just derived ourselves. This is all you need to remember. Understand? Okay, so we're going to start using it now. I just thought I'd show you how that was derived. You don't have to worry about it. So this implies that, let me write that properly. This implies that our integrating factor is always exponential the integral of px dx. There should have been dx here. and that is our integrating factor. So if you have a function, if you have an equation, a differential equation of the new form, then the first thing for you to do is to find your integrating factor using this. Then you multiply by the integrating factor, and then you write the left-hand side as that, and you continue. Let's take a question. Oh, in your book, there are steps. There are steps. Well, it's just exactly what we did in the previous slide. Okay. Maybe we can write down the steps. Step to follow if you are solving summary. Let's call this summary. To solve y dx plus p of x, y equals q of x. Step 1, find the integrating factor. Find the integrating factor. Find the integrating factor ix, which is equal to exponential integral of p of x. Step 2, multiply. So if I call this equation 1, multiply equation 1 by the integrating factor. Okay. Step 3, write left-hand side of step 2. Write left-hand side of step 2 as dx of ix to y. Step 4, integrate both sides. Okay, integrate both sides with respect to x to solve for y. That's all. Okay, that is dx of xy is equal to qx will imply ix qx like I wrote earlier, so maybe we stick to that. It will imply that ixy is equal to the integral of qx dx, and y can be made the subject. Okay, that's this is the solution. So these are the 4 steps you need to follow. Just wanted to write that. I explained that earlier, but just to put it in summary. Now that we have established how to find integrating factor. Okay, let's solve some problems quickly. Before then, I will play you an example from the book. Then we will solve. There are 1, 2, 3, 4, 5, 6. There are 6 questions from your book. I will do something, you will do something, then that's it. Just a sec. Integrating factor, page 696. Okay, I'm sharing my screen now. Can you see this? Okay, so this is what we have just done. Consider a differential equation of the form this. Generally, this type of equation is not separable. However, suppose there is a function ix called integrating factor, so that whenever you multiply this product rule is exactly when you multiply the left-hand side by ix, just like as I've explained, then we can derive the ix. So this is just the derivation of the ix. Don't worry about it. Then you could see this is the summary. So this is what I want to play for us. So we don't have to worry too much about that. Can you see the problem? Okay, so I'm sharing my audio also. Give me a thumbs up if it works perfectly.
In the chapter so far, we have solved separable differential equations, as well as homogeneous differential equations, which can be reduced to separable form using substitution. We now consider differential equations which can be written in another special form. dy by dx plus a function of x times y is a function of x. Differential equations of this form are generally not separable. However, we can solve them using the integrating factor method. We suppose there is a function I of x called the integrating factor, such that the derivative of the product of I of x and y is equal to the product of I of x with either side of the differential equation. We can use these relationships to derive a formula for the integrating factor I of x. It does not need a constant of integration. We then multiply both sides of the differential equation by I of x. On the left-hand side, apply the product rule of differentiation in reverse, and hence obtain an integral for the integrating factor times y. We then integrate to find a general size of the differential equation factor I of x. It does not need a constant of integration. We then multiply both sides of the differential equation by I of x. On the left-hand side, apply the product rule of differentiation in reverse, and hence obtain an integral for the integrating factor times y. We then integrate to find a general solution. Look at the differential equation in this example. We see it has the correct form for using the integrating factor method. The integrating factor I of x is e to the power the integral of p of x, which is 3x squared with respect to x.
Understand that?
We perform the integration. We do not need a constant. We then multiply both sides of the differential equation by I of x. Look at the left-hand side of the resulting equation. You should notice that 3x squared times e to the x cubed is the derivative of e to the x cubed. So we let u be e to the x cubed. Then we have u times dy by dx plus du by dx times y. Applying the product rule in reverse, the left-hand side is the derivative with respect to x of y times u, or y times e to the x cubed.
Do you understand that so far? Raise your hand, please, if you understand that. Karen, are you lost?
A little.
Say that again.
I am a little lost.
A little lost. Okay, I'm going to do an example also, but what is the integrating factor? Exponential e exponential integral px. Identify your p and q from here. Your p is this, and your q is this, right? So the integrating factor for this problem is exponential integral of this dx. We have established this already. So once you find the integrating factor, multiply to both sides. That's the second step, isn't it? And once you multiply to both sides, you will see that this left-hand side is always, if you do your integrating factor very well, it's always the derivative of your integrating factor times y. Always. Forget about the u, dx, whatever explanation. It's always going to be that. Because remember, in our proof earlier, we carefully chose ix so that this left-hand side will be d dx of ix times y, and that is how we derive our ix. So it will always, because that was the basis of getting an ix, isn't it? So it will always be ix times y. So you don't have to worry about thinking of product rule. If your IL is accurate, this is going to be the derivative of ix times y. Remember, y is a function of x, so you are going to use product rule. If you use product rule now, keep this constant, right? Differentiate this. This is what you get. Then keep ex cubed constant and differentiate y. This is what you get. So you can see that this is product rule result for this one. That's why it's a product rule in reverse. I hope that clarifies your confusion.
Yes.
Okay, let's move on.
We can now integrate both sides with respect to x. The left-hand side is simply y times e to the x cubed. How can we integrate the right-hand side? You should observe that the derivative of e to the x cubed is itself times the derivative of x cubed, which is 3x squared. So the antiderivative of 3x squared e to the x cubed is e to the x cubed. So for the integral here, the antiderivative is 2 times e to the x cubed. We also include a constant of integration. We divide both sides by e to the x cubed.
Okay,
You should
again.
observe that the derivative of e to the x cubed is itself times...
This is simply integration by substitution. Remember, the power on exponential is here. The derivative of the power is here. Okay? So just use your normal let u be x cubed. You differentiate, you integrate the way you know. You don't have to follow this. Am I making sense? If you will let u to be this, you find your du dx, you transform the variable to du variable. Do you remember that, everyone? Okay, and at the end, you'll be able to integrate. So just remember that. You don't have to follow exactly what is done.
Times the derivative of x cubed, which is 3x squared. So the antiderivative of 3x squared e to the x cubed is e to the x cubed.
Do it your way, okay?
So for the integral here, the antiderivative is 2 times e to the x cubed. We also include a constant of integration. We divide both sides by e to the x cubed to make y the subject. This is the general solution for y in terms of x to the x cubed. We also include a constant of integration. We divide both sides by e to the x cubed to make y the subject. This is the general solution for y in terms of x.
Understand? So this is how integrating factor approach is done. Let's take one from the book. I'll send a screenshot of that also. So this is all you have from the book, but there are a lot in the past question that I've just compiled together. I'll send that to you by the end of today or tomorrow. I'll show you some of the things I have found so far. Here, let's look for integrating factor. You see, show that this is the integrating factor for the equation, then solve. That's how it is done. Okay, these are some of the questions. Solve this equation by separating variables. Solve the same, this should be same, not same. Same equation by homogeneous, solve by integrating factor. The same question in 3 ways. Okay, these are all past papers, And I also pick some from the revision village, which are here. So once I arrange it properly, I'll send it out. You can practice at your, I think I'll probably pick an assignment from here by the end of today. Okay. All right, let's go to the board and solve a question from the book. Let's pick this problem. I send this to you first. So you can look through that. Let's pick question 2. Okay, that looks complicated, right? Let's pick question 2 and solve that together. So with that, you should be able to do any other difficult question. example. So let's say that is example 2. Example 1 is the audio. Example 2 is taken from exercise 25G. Question 2. And the question says, solve sorry, my pen again. I forgot to change the battery again. Solve cos x dy dx, okay, equals y sine x. Yeah. Y sine x plus sine 2x given y of 0 equals to 1. Let's solve this together. So I will need contribution. Please turn on your mic so we can discuss together. What is the first thing we should do? What's the first thing that must be done? Please talk to me.
Y sine x on the left side.
Say that again.
Y sine x on the left side.
Okay. So it said y sine x on the other side. Okay. So cos x dy by dx minus y sine x yeah.
Wait, actually, shouldn't we do something about the cos x?
Can I take it one step at a time, sir? Y sine x equals to 2x. You're right, but we have to take it one step at a time. Then that could be the second thing, or you could do it first. You do the cos x first, then you move things around. Your choice. Okay. Do you prefer the other way, Mr. Chang? Speak louder, please.
I think it's around the same.
It's the same. Anyway, so let's divide by cos x first. Dy by dx equals to y sine x over cos x plus sine 2x over cos x. Karen, how do we simplify this? Callista, get ready. Simplify one of them for me, Karen.
Do you mean like the sine x over cos x?
Yep. Y, Come on.
Y 10
And
x.
X. Why did that take you so long? Are you sure you are focusing on this? Miss K?
Yes.
Okay. Need attention here. Callista, how do you think we can simplify
10
this? Say that again.
10 to x.
I think it's a mistake.
10
This should
to
be x. This should be x, not 2x.
Is it?
Yeah, because we divided by sine x, right? Oh, thank you, Ethan. I just saw your message. It should be, we divided by cos x. We try to remove this by dividing by cos x. Okay, so it's not cos 2x, so we can't get tan 2x. What else do you propose?
1 over 2 tan x.
1 over 2 tan? What do you mean 1 over 2 tan? Sine 2x over cos x. What do you propose we do? Krista C, try. Callista, well done. Say that again.
2 sine x.
2 sine x. Where does that come from?
Because sine 2x is 2 sine x times cos x.
That's what I want to hear. Don't give me the final answer. What would you write in the exam? 2
Sine x cos x.
Good. 2 sine x cos x
Divided by cos x.
divided by cos x. Thank you. Callista, do you understand that?
Yeah.
Then your cos x cancels. So you have your dy dx. So now I can move the left-hand side. On the other side, I am having only what? I'm having only 2 sine x. Does everybody understand this? So your first goal is to make sure that it looks exactly like this. That's your first goal. Okay? It must look exactly like that. And that's what we have just done. So what is your px? Let's ask someone. Hold on. What's your px? Let's ask Nakita.
Px is negative 10x.
Yes, px is negative 10x. So you can write it by saying, oh, px in this case is negative 10x. Okay, remember you've compared with dy dx plus pxy is equal to qx. Okay, that's what you have compared with. So px is negative 10x. So in that case, Venner, integrating factor will be what?
Exponential. The integral of negative 10x dx.
And that will be, how do we solve that? Let's ask Clarissa. How do we find that? How do we integrate negative 10x dx?
The integral of negative 10x would be
You don't have to give the final answer. You can guide us through the process. What is the first thing to do? And it leads to the answer. What is the first thing you will do to integrate tan x into minus tan x, I mean?
it will be ln cos x.
Ln cos x. How do you get that? Integral of what?
Negative sine x over cos x.
That's it. And we all know that this ix now will become exponential because the derivative of cos is minus sine. So this is ln cos x, isn't it? Dx. No, ln cos x. There's no need for plus c. Now, Krista C, what is ln cos x? What is exponential ln cos x? Sorry, not ln cos x. What is exponential ln cos x?
Cos x.
Just cos x. I hope everybody understands that. Because a raised to power log to base a of anything is equal to that thing. As long as this and this are the same, it can cancel. This is exponential. This is logarithm to base e also. That is why it cancels. Understand? Okay, so having said that, now that we have our integrating factor, Lillian, what do we do next?
Write as d dx.
For this equation 1, I call the reduced partition equation 2. What do we do with integrating factor?
So you write as d dx.
Hmm?
Do we have to write like the ixy first, or can we just substitute in straight?
No, I would rather you give me something explanatory, not too fast. What is the second step in our summary? After you find integrating factor, it's on the board.
Multiply both sides by ix.
Yes. So now we multiply both sides. That's what we should do. And what equation are we multiplying in this case? 1 or 2? You all right?
Yep.
Multiply 2 by ix, because that is the one that looks like the format that we need. Okay, I need everybody to go through this procedure. Okay, so if you multiply equation 2, Crystal C, tell me what it looks like now, quickly.
D over dx.
Mm-hmm.
Then
Equation 2 is on the
cos
board. Equation 2 is on the board, and your ix is also on the board, so I do not expect you to look down, Crystal. Just tell me based on what is on the board, not by looking at your book. The instruction is clear. Multiply equation 2 by ix. Ix is cos x. So multiplying equation 2 by cos x. Tell me what it becomes quickly.
d dx times
D dx. What? I didn't get the second part. That's what I mean. I'm not saying you're wrong. D dx. Wait. You said d dx? How did you get d dx? You are jumping
ui
stuff.
dx.
Come on. Multiply equation 2 by cos x quickly. You're thinking too much. You're doing what I'm not asking you to do. I'm waiting and you're mute.
ui dx times cos x.
That's all I want to hear. So just write cos x. Good. Times dy dx, because you don't want to put it in front. Then minus,
y tan x times cos x.
Good. That's what I want to hear. Don't do what you're not asked. Take it one step at a time. Is equal to?
2 sine x times cos x.
Good. Nakita, take it from there.
D dx times y cos x.
So this will be d dx times, before then, you are welcome to simplify. Tan is going to be sine over cos, yes?
Yes.
So this is actually cos x dy dx. Karen, get ready. This is sine x. I'm just giving you these steps. You don't have to show this. So you see why it is that. So this left-hand side becomes cos x dy dx. Always write cos x because before dy dx, please. This is y sine x, and this is 2 sine x cos x. I'm writing some things intentionally. So, Nakita, the left-hand side will be the dx of what?
Y cos x.
Y cos x. It will always be y cos x. You don't have to even check if it is right or not. It will always be y cos x. But let's check. Derivative of y, keep this constant and differentiate y, you get the first one. Then keep y constant and differentiate this, you get minus sine. That's the second one. That's it. That's the reason I simplified and I didn't leave it here. Just so you see it. It will be equal to what, Karen? on. It will be equal to
sine 2x.
that's sine 2x. So if I want to isolate y cos x, Callista, it will be equal to what? Callista, please. I want to isolate what I have in the bracket. It will be equal to what? Mr. Chen, get ready. Can Callista hear me? Your screen is frozen, or maybe you are just looking like that. I don't know. Okay, I think your eye is blinking.
No, I can't think. Wait.
If I want to isolate this, I want to remove this. What do I do to the other side?
Integral?
Integral, that's all. Just integrate. Integral sine 2x dx, that's all. Okay, Mr. Chang, so what is that now?
Negative half cos x.
Negative half cos x. Does everybody understand what he did? He did cos 2x divided by 2, right? Then plus c. Okay, now we have initial condition. So now we're going to use our initial condition to get c. So y0 equals 1 means when x is equal to 0, y is equal to 1. That's what it means, right? So if you substitute into this, just a sec. So if I call this equation 3, so put into 3, substitute this into 3, I get 1 times cos 0 is equal to minus half cos 0, right, plus c. Cos 0 is 1. 1 is equal to minus half plus c, which means c is 1 plus half, which is 3/2. So therefore, the particular solution, because this is not a general solution anymore, the particular solution of that equation is, okay, is y. You see, I found my c before I isolate y. Y cos x equals minus half, right, cos 2x plus 3/2. So if I divide both sides by cos, I get y is equal to minus half. Instead of dividing by this, I could write it as sec, right? Sec x cos 2x plus 3/2 sec x also, something like that. I'm not sure cos 2x sec x can be simplified to something reasonable, because if you write your cos in terms of cos, this is what I mean. Cos 2x divided by cos x. Cos 2x is going, in terms of cos, is what? 2 cos squared minus 1, right? Divided by cos. So you're still going to have 1 cos. Then the other side will be a sec. You get what I mean? Guys, do you understand what I mean? So there will be a sec eventually. So that's why I'm just going to leave it at that. You might end up checking the back of the book and you get the other formats. It's still the same thing. So you might have that then. And we are having your 3/2. No, there's a half here. If there's a half here, there will be half times this. And there will be half times that. And 3/2 sec x. Let's see. So half times that would be cos x. Then this would be minus half sec x. Oh, I think that's quite more reasonable. Let's simplify it like that. I think that's more reasonable solution. Let's write that as the final answer because it doesn't involve too many complicated trig identities. Okay, so let's try to remember this. Sorry. So y is equal to, from the previous screen, minus half is equals first or sec, okay, sec x cos 2x minus 3 over 2 sec x, minus or plus. Please confirm if you understand what I've done so far, please. Hello? Can you raise your hand if you understand what I've done? Okay, all right, thank you. So let's simplify this. I don't think it's necessary, but let's just see. This is half sec x will be 1 over cos. And cos 2x in terms of cos will be 2 cos squared x minus 1. This is 3 over 2 sec. Oh. Just if necessary, in case the question says show that the solution is equal to this, you have to simplify to that point. Otherwise, you are welcome to leave it the way it is. 1 over 2, if you open the bracket now, 1 over 2 cos x, we multiply 2 cos squared x, then minus another 1 over 2 cos x, plus 3 over 2 sec x. That's what I'm trying to do. So this 2 cancels 2, so you have negative cos x. Please tell me if I've made any mistake. This is going to be minus half sec x, 3 over 2 sec x. So that's the reason I'm simplifying, because this can be merged. So 3 over 2 minus half is 1. So basically, I can say my y is minus cos x plus 1 sec x. So it's likely the question says show that the solution, the particular solution is this. That's my point. Okay. But I would say that this is also okay to stop here. Any questions? So this is how to solve that. Quickly, we're not going to extend to more than 1, like I said. So even if I have to do Newton's method with the next thing tomorrow, it's fine. But I need you to practice this in this class. I need you to try question 1b now. Okay, everybody try question 1b now. 1b, I've sent the picture already. I'll leave this on the screen. Please follow the steps. One B. I'll pause the recording so we do not have to record the unnecessary parts. That. If there's a minus sign, please make sure your minus goes with P. That was why if you look at the screen, I wrote it separately. Px is minus tan x. Okay, please make sure. It can be tempting and sometimes confusing. Well done. But I think every other thing looks okay, just that particular one. Integrating factor, Nikita. Wonderful, Nikita, that's correct. We close in about 12 minutes. Those of you that already finished, can I ask you to try question 1A? Yeah, that should be easier. Try question 1A quickly. And after 1A, you can try 3A. Okay, we close exactly 1. So let's see what we can do within 10 minutes. 1A, then go to 3A, go to 3B, go to 3C, like that. Your homework will not be from this exercise. Your homework will come from the past question. I'll just pick one thing for you. Okay. And since it's the only one idea, so I might just look for 2 problems or 3, I don't know. By the way, Nakita, when you're submitting your own work, can you give me a more clearer picture? Okay, I've graded some homework. I'll be sending them out after this class. And those of you that sent in your homework before day breaks, I received your email when I woke up this morning. Well done, everybody. So let's get more entries in before 1 o'clock. The first day of school or the first 2 days of school will be to review and solve more problems on this, I promise, so that if the first day is enough, that's fine. Or we could use the first 2 days to review and solve questions in general, because your exam will be by then. Then we start statistics. Oh, I can't wait. We close in maximum of 9 minutes. I think I'm going to start using Mr. Topsy's pen from tomorrow until my battery is fixed. Another entry received. Okay, that's Mr. Cheng, Honorable Cheng. Okay. No, Ethan. Can you hear me, sir? Okay. Just an observation. When you integrate, you put your plus C. Your plus C is not when you get your Y.
Okay.
Okay. Your plus C is right after you integrate. So your plus C should appear where you have exponential negative 3xy is equal to minus half, right? Minus half exponential x plus C. That's where your plus C should appear. Because your solution involves 2 terms in exponential, and with what you have done, you didn't give room for that. Okay? The other side contains plus C. Then when your exponential 3x goes to the other side, it stays with it. Okay, so please adjust that. That's a wrong assumption, sir. Nakita, another stuff received, 1A. I'm checking now. We have 7 more minutes to wrap up, guys. So please send me something so I can give you feedback before we go. This is correct, Nakita. This is a general solution question. It's not a particular solution question. So that is absolutely correct. So I like how you structure your work. You brought out the, I'm going to share my screen just to maybe give someone a guideline. So if you look at this, guys, you can see how she put this. She puts the px out, right, integrating factor, and I like that. You don't have to do it. I'm only saying that minimizes the error of not including negative if there are negative, okay? That's very good. I like how this was structured. And even the previous one, you did the same thing. Very good. Mr. Chang, look at the board now. Please look at the screen. You see this? Can you see my cursor?
Yeah, I fixed it.
So you have to, because remember, you are integrating this, right? The integral of this is what consists of the C, not the entire thing. Because the entire thing is coming back with a function of x, right? So if you multiply by a function of x, it's not going to be c. If this was a number, maybe like 4, then you are right. So assume, okay, you can put a plus c eventually, because constant times constant is still constant. Okay, but you're dealing with a constant times a function. That is not a constant. So that was the misconception. Okay. All right. Thank you. I'm expecting more. Who's that? Clary. Okay. Okay. I think I'm just saying your first entry, Clarissa. My bad. Yeah, that's correct. Oh, one solution in 2 pictures. Got it. Absolutely correct. Well done. Okay, your work is perceived. Karen, there's a minor mistake somewhere.
Yes.
Oh, look at your equation 2, Karen. Are you there?
Yes.
Can you call it out for me, please? Your equation 2. What's your label equation 2? Call it out.
What do you mean called? Oh, negative.
Negative. Can you see what is wrong then in the last line?
Yeah.
That
the
negative.
C.
That's it.
Mm-hmm.
Every other
Okay.
thing is perfect.
Okay.
I kind of watch all the Christmas movies on Netflix, like everything, literally everything.
Mr. Daniel,
Yeah, you have a movie
can I
suggestion
send
for
it
me?
to you later? No, can I send it to you later? My pen just ran out of battery.
Okay, that's fine. That's fine. You can log out too if you want. Okay,
It's okay.
log
It's
out
just
too
a
if you
pen.
want. Yeah, we close in like 3 minutes.
Mm.
I'm just trying to bore everybody with my story. You know, when you sing like that, people get to give you like candy. So I'm singing hopefully that Clarissa can say, oh, take this cookie. Cookies like that will not be shared with Krista or Karen, the favorite foodies of our class. By the way, do you guys notice Krista came with food and she never shared with anyone? At the beginning of the class, she had food. That's too bad. What kind of friend are you, Krista? You had the audacity to show us the food without sharing. Oh my God. All right, 3 minutes to go. Send me something if you want a feedback. Otherwise, I wish you the best. I will also send you a question in the revision exercise at the back of your book if anyone wishes to try them, or maybe not. Maybe we can look at those in school so you don't have to ruin your holiday totally. Nakita, have some fun, okay? This is holiday because I don't trust you. Don't go solving problems across. Everybody is doing Happy New Year. I don't want to see you working on the worksheets, okay? Come on. Life is not that serious, okay? This one. This might be my last entry for today. It's 12:58. Mr. Cheng. You haven't adjusted the first one, right, Ethan?
Oh, do I need to send it to you? I fixed it. I just didn't send.
Oh, okay. If you don't mind, send it also, please. So I'm looking at number 1 now. 3 plus that. Number 1 is absolutely correct. Integrating factor is this. Can you please explain? You just wrote integrating factor equals exponential this, Then the next thing I saw is exponential this times this. I don't know what the question is. I don't know how you got that. So the first thing I will expect is the original question, okay, before that line integrating factor, then an instruction that says multiply integrating factor to equation 1, if you label the original question as equation 1, before all this. Understand? Can you please be more explanatory and not assume, he knows what I'm doing. Dude, I don't know what I'm doing. Okay, like this 1B you've corrected. You showed me the original question. You showed me P of X. So why do you become lazy suddenly, mister? Anyways, that's fine. All right, guy. Oh, Callista, I received something. I thought you ran out of battery. Oh my God, what is wrong with this girl? Callista, that's correct, by the way. I've seen everything you sent in. That is absolutely correct. Okay, good job, everybody. We'll see you tomorrow. Have a nice day. If you are still working, please, you can send them in. I'm happy to type a feedback and send back to you. All right. For now, I'm going to close the meeting. Everyone, tomorrow, enjoy the rest of the day. See you tomorrow. I received one entry. I'll look at it.